everyone. Today we're going to be going over the lesson 7.1 notes on square roots. So let's start out by defining a square root. A square root of a number is a number that, when multiplied by itself, equals the given number. When multiplied by itself, it equals the given number. Every positive number has a positive and a negative square root. And then we have the definition of a perfect square. A perfect square is a number with integers as its square roots. Okay, so let's look at example 1 together to help us better understand this definition. Example 1 says, finding square roots of a perfect square. We are asked to find the square roots of 49. Okay, now this is a positive number. In our definition, we know that a positive number is going to have two solutions. It's going to have both a positive and a negative solution. So the square root of 49 should have a positive and a negative solution. 7 times 7 equals 49, and negative 7 times negative 7 also equals 49. This proves our definition that each positive number will have both a positive and a negative answer as their square root, right? Because we know a positive multiplied by a positive is a positive, and a negative multiplied by a negative is also positive. So the symbol I just drew here for a square root is called a radical sign. It is used to represent a square root, and the number under the radical sign is called the radicand. Now we have a little table here showing us the notation for a positive square root, a negative square root, and for both square roots. Okay, so when you see just the radical sign, that is asking for a positive square root. When you see a negative sign in front of the radical sign, your answer should be a negative square root. And when you see this sign here, it looks like a plus and a minus in front of the radical sign. That means that they are looking for both answers. Okay, a plus written above a minus sign, this is read as plus or minus. So we would say plus or minus the square root of 16, and your answer is plus or minus 4. That's how we read this notation. Now let's go into example 2, where we are going to find some square roots. So the first problem gives us the square root of 25. Now it's important to pay attention to whether there is a plus or minus sign in front of our radical sign. I don't see one here. We know when there is nothing in front of the radical sign, it is looking for the positive answer. So this would be 5. We know that 5 times 5 equals 25. 5 is the number that you can multiply by itself to get 25. In the next example, we have a fraction under our radical sign, and we have a negative sign in front. So we're looking for a negative solution to this problem. Now the square root of 9/16. We know that when we multiply fractions, we are simply multiplying straight across the top and multiplying straight across the bottom. So this would be the same as the square root of 9 over the square root of 16. Okay, and that is because we multiply straight across when we are multiplying fractions. We know that you multiply 3 times 3 to get 9. And we know that you multiply 4 times 4 to get 16. So your solution for this would be negative 3/4. Or in other words, we can check our work. 3/4 times 3/4 negative 3/4 rather, equals 9/16. Negative 3 times negative 3 equals 9, and 4 times 4 equals 16. Okay, so we can see that this is true. Our solution here would be negative 3/4. Now, in our last example, we have a decimal. And in front of our radical sign, we have the plus or minus notation. So this should have two solutions, a positive and a negative solution. Because we know that 1.5 squared equals 2.25, the square root of 2.25 would be plus or minus 1.5. We can multiply 1.5 by itself to get 2.25. We can also multiply negative 1.5 by itself to get 2.25. Now, if you didn't know that 1.5 squared was equal to 2.25, you could rewrite this as a fraction, and that may be a little more helpful. So if we were to do that, we would have plus or minus the square root of 9 over the square root of 4, right? 2.25 written as a fraction is 2 1/4, and 2 1/4 equals 9/4. And when we have plus or minus the square root of 9 over the square root of 4, it becomes a little bit easier to get a solution. Plus or minus the square root of 9 is 3, and the square root of 4 is 2. Plus or minus 3/2, which is the same as plus or minus 1.5. Okay, so if you ever come upon a problem like that, you could always try rewriting it as a fraction, and that may be helpful. All right, now there is a comment here that says squaring a positive number and finding a square root are inverse operations. You can use this relationship to evaluate expressions and solve equations involving squares. Now, we have spent a lot of time on equations this year, and during that time, we have gained an understanding of what inverse operations are. If I had an equation like x over 2 equals 5, you guys would know to solve that, we need to use inverse operations. The inverse of dividing by 2 would be multiplying by 2. And whatever I do on one side, I have to do on the other. And you would arrive at the answer x equals 10. Just like multiplication would be the inverse operation of division, taking the square root of a number is the inverse of squaring a number. So let's look at how we can evaluate these expressions when we have that in mind. So evaluate each expression. 5 times the square root of 36 plus 7. When you have a number in front of a square root, that is symbolizing multiplication. Just like if we were to have 5x, we know that that is 5 times x. It's the same here. This is 5 times the square root of 36. So let's take that square root first. The square root of 36 is 6. And this becomes 5 times 6 plus 7. 5 times 6, we are going to simplify to 30. 30 plus 7 equals 37. So when we evaluate this expression, we get an answer of 37. Now let's look at B. In B, we have 1/4 plus the square root of 18 over 2. Now, if this looks trickier because we have a fraction under the square root symbol, we can just simplify this, right? I'm going to start by doing that. We can rewrite this as 1/4 plus 18 divided by 2 is just 9. So this is 1/4 plus the square root of 9. We know the square root of 9 equals 3 because 3 times 3 is 9. And we get an answer of 3 1/4. And let's look at our final example. We have the square root of 81 squared. minus 5. Okay, so squaring something and taking the square root of it are inverse operations. In other words, they cancel each other out, okay? And I'll show you why. Let's say we take the square root of 81. Remember, we're going to do what's in parentheses first. We know the square root of 81 is 9. So this becomes 9 squared minus 5. Well, 9 squared is 81. So now I have 81 minus 5, and I'm going to get 76. We could have done this without this step here. We could have completely skipped this step, just knowing that this squared and this square root cancel each other out because they are inverse operations. We can jump right to 81 minus 5 equals 76, okay? Because taking the square root of 81 is just 9, and then when we square it again, it becomes 81. Okay, so that's how we can tell that this cancels each other out and they are inverse operations. Let's move on to example 4 with a real-life application of this problem. The area of a crop circle is 45,216 square feet. What is the radius of the crop circle? Use 3.14 for pi. Okay, well, it's important to know the formula for area of a circle. Area of a circle is pi r squared. And now we know the area of this circle is 45,216 square feet. So this number is equal to pi r squared. We need to solve for r. It is asking us what is the radius. Okay, so we know how to solve for a variable. We need to use inverse operations. So first, let's get rid of this pi that is written out front. Remember, when we are solving for a variable, we do order of operations in reverse. So we're actually going to get rid of the multiplication before we look at the exponent. It says to use 3.14 for pi, and you may get out a calculator. When we divide 45,216 by 3.14, you should get 14,400 equals r squared. Now we know what r squared equals. To find out what r equals, we need to do the inverse operation. The inverse of squaring something is taking the square root. Now this squared and this square root sign cancel each other out. Whatever we do on one side, we have to do on the other. So now we must take the square root of 14,400. And when you take the square root, you should get an answer of r equals 120. That's it for today's lesson. You should have a few problems to try on your own, and your homework is in Big Ideas. Have a great day, everyone.